All right, guys, last question. Okay, a graph of g double prime is given. So this is a second derivative graph. That's noteworthy right there because we haven't really looked at one of those before. But we can still answer a lot of questions about it. On what intervals is the g of x, the actual derivative, concave up? Okay, concave up should make you think that g double prime of x is positive for concavity. And concave down, g double prime of x would be negative. So let's look at this graph. This graph is the second derivative. Positive values are above the x-axis, negative values are below the x-axis. So when is g double prime positive above the x-axis? And that occurs from about -1 to 0. And that's all I see. So that would be the only answer here. When is it negative, meaning below the x-axis? That occurs from about -2 to -1. And after 0, from 0 to, it looks like 2 here. All right. Now we're being asked, when is g prime increasing and decreasing? All right, so let's look at that chart again to see how they relate to one another. I said that f prime was a higher order, f double prime was lower order. So f prime is increasing when f double prime is positive. Okay, well, we just answered that right here. The second derivative is positive from -1 to 0. So that's when g prime is increasing. Decreasing, g prime is decreasing when the second derivative is negative. And we just answered that over here. The second derivative was negative from -2 to -1 and 0 to 2. All right, you are definitely going to have a graph. You are going to be asked about the concavity, increasing, decreasing. You might be asked about horizontal tangents. If I ask you about horizontal tangents, I have to be showing you the derivative. And on a derivative graph, a horizontal tangent, meaning a slope of 0, occurs all the times the graph hits the x-axis. So like on this other one right here, where this was the derivative, the horizontal tangents would occur every time the derivative hit the x-axis. Because this literally means a slope that is equal to 0. And horizontal tangents have a slope that is equal to 0. I could also ask you about maxes and mins. And don't forget that maxes occur when the derivative changes from positive to negative. Mins occur when the derivative changes from negative to positive. So here's the derivative. Here's positive, negative, positive, negative. Positive to negative is a max. Negative to positive is a min. Positive to negative is a max. And negative, and so on. We don't know exactly what's going on now. So make sure that you can answer all of these kinds of questions. The only other type of thing that's not explicitly on this review sheet, but we might have to do, is we might have to take a function just like this one, and using, like we did in class, using the first and second derivatives, we might have to graph that function. Okay, and that's just like we did in class. You guys had a worksheet on it on Monday, and that would just require you to do 2 number lines, to do the first derivative, to do this, the second derivative like we have over here, and the first derivative, and find all the values and put your pluses and minuses in, put them together to make an actual sketch. Okay, all right. Hopefully you guys will do great. I know you will. Thanks.